This tutorial covers how to contribute a pod to the mdtf diagnostics repository. To start off, here are a few links for developers. The first is a documentation for developers that describes in more detail the steps I'm going to cover in this tutorial, as well as some extra instructions for things like Git commands and coding best practices. The next link goes to a cheat sheet, which is for more experienced developers. That is an even shorter summary of the information in this tutorial and the documentation. And finally, I'll direct you to the GitHub discussions board for the repository, where you can find information that applies more generally to the framework, as well as things like Python issues. To start off, I'm going to work from the assumption that you have already forked the Node.jftl mdtf diagnostics repository and created a local copy on your machine. You're going to start by checking out a branch for your pod off of the develop branch. Then you're going to create a new directory for your pod with a doc subdirectory in the diagnostics folder. You're going to copy all of the template files from the example subdirectory in the diagnostics directory into your pod directory. You can start by modifying the driver script to match your pod name and add the contents of your pod to the driver script. You can also add additional Python modules if your driver launches more than one file. You are going to modify your copy of the doc/example RST file to match your pod name and add a description of your pod. You can go into a little detail of the science of your pod, add some references, consult the template for the information we would like, and proceed from there. You can add reference figures if you choose, but they are not required. Just be sure to delete the template figure if you have copied it over to your directory. Then you're going to want to modify the example HTML template that will contain the information for your pod output. Modify the output description, title, paths with the names, the relative paths to, and the HTML labels of the figures your pod generates. Then you're going to modify the settings.jsonc file to include the variables, dimensions, output frequency, and metadata that your pod needs. You can modify your add content environment file names and packages required by your pod to the runtime requirements block. Most of the packages required by the pods are located in the env_python3 base YAML. This is in the source conda subdirectory, so you can look at the YAML and see exactly what packages we already have. If you need additional packages, you can go ahead and open an issue and we will add them to the appropriate YAML file. You can create your own content environment file for testing. Oftentimes it's easier, especially if we can't address your issue request for more Python 3 modules right away. But just do not include this in the final pull request, since building environments requires a lot of time on shared file systems. So we prefer just to maintain a few larger YAML files rather than several small ones. So here is a general set of recommendations. First, pod variables must adhere to CMIP, GFTL, or CESM/MCAR conventions. The variables and metadata referenced by the framework that are required for the pre-processing that pertain to these conventions are located in the data field list _/convention name JSON-C files. If you need additional variables, or say you need level field defined for a specific variable in the field list file or several files, go ahead and open an issue requesting the variables in the required convention, and the developers will add them for you. The data modifiers JSON-C is an additional file that can contain parameters that will help differentiate among variables with the same standard name but different dimensions. So right now we just have an atmos height parameter to indicate to the framework that it should use 3D variables defined at height above ground instead of 4D variables, or alternately a 3D slice of a 4D field. So most commonly this pertains to atmospheric temperature, where you can say you have the standard name temperature but it's defined at 2 meters or 10 meters, or it can refer to a 3D or 4D field. Finally, you're going to test your pod with the framework. So go ahead and modify the source default test.json.c file as described in the introductory tutorial that's also available on the NOAA GFDL YouTube page. And add your pod to the pod list, modify the case root if you're working with a different data set than the defaults, and any additional fields that you need, and go ahead and run your pod with the framework. Once you've done the initial work and added all your files, you can go ahead and push the branch that you made to your remote mdtf diagnostics fork. You do not have to do this all in one go. In fact, I recommend getting everything set up to start you off, add all your files as described in this tutorial, push the changes, have your branch ready to go. And then you can continue working on your pod as you need. I do recommend strongly pushing at least daily if you're doing active development on your pod to ensure that you have a backup of your files at any given time in case you have issues on your system or simply want to work from a different machine. Once you have pushed your branch to your remote fork, go ahead and open a draft pull request for your pod and submit it to the NOAA GFDL mdtf diagnostics develop branch. This will just let us know that you started working on your pod. We won't be monitoring it closely. And I've linked to instructions below as to how to submit a draft pull request. And then once you're ready for a final pull request, you can move it out of draft mode and we'll begin the review process. I will describe this process in a future tutorial. Open an issue for assistance with problems that don't appear to originate from your pod. So if the framework is throwing errors with the preprocessor, it's having issues handling your data, or you're getting general bugs that are leading to, say, a stack trace that is pointing to somewhere in the framework, let us know, and we'll see if your pod has either exposed a bug or we just need to add some additional features to handle your pod or data set. To start off with, I am within the overall mdtf structure and in the mdtf diagnostics repository. So here, if I just do an ls and then cd to mdtf diagnostics using the terminal output, you can see that looks like here. And I have the directory pulled up in the left-hand panel as well. So here's mdtf diagnostics. You go into diagnostics. Here's where you're going to add your pods, so you can see all of our currently supported pods. And here is the example pod in the template files. So in the doc, you'll see the example RST file, a sample image that gets referenced in the RST file. Here's the driver script, the HTML file, and the settings.jsonc file. So if we start by looking at the example diag.py file, you'll see we have very detailed comments just describing information you might want to include in your own driver script. So here's an example just showing how you go and import modules, simple things like that, how you reference some of our framework environment files that are described in the documentation. So here is how you pull a directory path pointing to a file that pertains to a variable. Here we're just using a temperature variable. Here is another OS environment call, so things to get the variable name and the time coordinate value. Scroll down below, here is the output path directory. So here is where the output will be written to. So you can see it's in the working directory within the model subdirectory, netcdf. So here's an netcdf file output. Here is a plotting subsection. So that'll give you a demonstration of how to plot some output. You can see here, because it's using PostScript, it's appending to a PostScript subdirectory, but if you use a .png, you can omit this PS subdirectory. So if we move over to the HTML file, again, we have detailed instructions here in the comments. Please also remove any example comments from your files once you've copied the templates over and added your own information. Here, is where you'd add the title of your diagnostic. You can leave a reference to this banner file that's plotted by default in all HTML outputs. Here's a description. Here's another title for the actual figure. You can see these double bracketed variables are referencing environment variables. You can leave those put. Those will populate automatically, but you'll want to change any non-bracketed information to match the output of your pod. So you can see here we're plotting a portable network graphic file. We have one that's going to the model subdirectory. So this is a relative path within the pod output directory. And then similarly for the obs, if you're plotting output that pertains to observations, you put them in the obs subdirectory. If we look at the settings JSON file, you can see here, name of the driver script, long name, the realm, so this can be Atlas, land, ice, ocean, whatever component your pod is doing analysis on. The description, here's where you'd add your custom environment variables, if you have any. Here's where you'd modify the Python modules that are required. So as I said before, you're probably going to be using the Python 3 environment file, but if you are wrapping an SCL script or an R script, you would reference the env underscore NCL base or env underscore, I believe R base is the name of the file. You can find these in source conda subdirectory. Here's where you define your dimensions. If you are working with 4D variables in addition to 3D, you can add a level dimension as well. And here's where you'd add your variables in the metadata. So here we have air temperature, the output frequency is monthly, units, the dimensionality, and you see we have the modifier here because we're just working with a 3D atmospheric temperature variable. It's not a 4D field or a slice from a 4D field. And then here, we go over to the RST file. It provides information and headings. So just fill in what we request below as best as you're able. You can see this is very similar to an abstract for a paper. And then finally, here's the default tests JSON-C file. You can go ahead and modify this case list block and comment out what you need, or simply add a block that pertains to your own testing. But again, make sure you just have one case block that is uncommented. So first, modify your case name if you're working with a different data set. Change the convention to match your needs. Modify the first and last years. And then add your pod to the pod list. And then you will run this as described in the introductory tutorial. So that is all on how you go about contributing a pod to the mdtf diagnostics repository. Again, please check out our other tutorials on the NOAA GFDL YouTube page.